What if we just mapped the universe and it changed everything we thought we knew? What if I told you we've just built the largest 3D map of the universe ever created? Not a small patch of sky, not a few galaxies, but tens of millions of cosmic structures spread across billions of light years. And what we found might rewrite the future of cosmology. A project known as the Dark Energy Spectroscopic Instrument has just reached a historic milestone. Its mission sounds simple, but it pushes the limits of human technology. Map the universe in 3 dimensions, not just positions, but distances and how the universe has expanded over time. At first, the goal was ambitious, around 34 million objects, but the final result? 47 million galaxies and quasars, each one a marker in space, each one a message from the past. Because when you look into space, you are looking back in time. Some of these objects are so distant, their light began traveling toward us billions of years ago. So this isn't just a map, it's a timeline of the universe itself. But mapping wasn't the real goal. The real target was one of the biggest mysteries in physics. What is causing the universe to expand faster and faster? The answer we've relied on for decades is dark energy, a mysterious force making up most of the universe, pushing everything apart. And for a long time, scientists believed something very specific, that it never changes, that it is constant. This idea is called the cosmological constant, a stable rule, a fixed property of the universe. But now, that assumption is being questioned. The early analysis of this massive dataset reveals something unexpected. Dark energy might not be constant. It might evolve over time. And even more surprising, it could be weakening. This isn't just a small adjustment. This is a potential shift in our understanding of reality. Because if dark energy changes, then the future of the universe changes with it. For years, the leading prediction was clear. The universe would keep expanding forever, faster and faster, until everything becomes cold, dark, and isolated. But if dark energy weakens, that future is no longer certain. Imagine this instead. The expansion slows down. Over billions of years, it stabilizes. Or in a more dramatic scenario, gravity starts to take over again, pulling galaxies closer, changing the ultimate fate of everything. We don't know yet which path is correct, but with 47 million cosmic data points, we are closer than ever to finding out. And this is only the beginning. The project is still ongoing. Future observations will focus on harder-to-see regions, areas hidden behind the dust of our own galaxy, and faint, distant red galaxies, barely visible with current methods. The goal is to expand the map by another 20%, making it even more precise, even more revealing. The full analysis is still underway, and the most definitive answers are expected in the coming years. But one thing is already clear. We've crossed a boundary. For the first time, humanity is not just observing the universe. We are mapping it across time itself. And in doing so, we may have uncovered something deeper, something unsettling. If something as fundamental as dark energy can change, what else have we misunderstood? The universe has always been sending signals. Through light, through motion, through structure. And now, we finally have the tools to read them. But what they're telling us might be far stranger than we imagined. Because this discovery isn't just about where galaxies are, it's about the possibility that the universe itself is not behaving the way we thought at all. This is space know-how, and the universe is still full of secrets waiting to be mapped.